because we don't have a lot of time, only this week and next week only. Okay. So see, so we'll go through plainly. Okay. So this is basics of networking basics. Okay. So start with actually what is network? What is network? A interconnection of two or more devices is called a network. For example, I have a computer. So we use a word called device instead of computer because of not only a computer, your mobile phone, laptops, tablets, TVs, everything is getting connected, right? That's why we are using word device. Okay. So just like for our understanding, we have a two or three computers are there, and we have a switch and we are connected. Meaning is a network is created. Network is created. Okay. So this is for example PCA, for example A1, B1, C1. These are the three computers are connected. So the connection of two or more devices, interconnection of two or more devices is called a network. So I created a network. What is a networking? Communication between two or more interconnected devices. If you make a communication, if you make a communication between A1 to B1, A1 to C1, or C1 to A1, or a B1 to A1, or B to C, C to B, like this. If these devices are communicating each other, okay, means they communicate each other, meaning is it's a networking. Okay, if communicating means networking, connection means just a network. Okay. Similarly, I have another network. Maybe I have another network. Okay. For example, I have another computers are there, and I created a network. So this is separate network, another network. For example, this is network 1, this is network 2, maybe this is network 3. There are different networks. If you can able to connect, if you are able to connect these networks, so that is internetworking. For example, I have a router. Okay, I connect through router like this. Maybe like this, or maybe I can use another router. Here it is. So these networks are connected through, you are able to connect these networks, right? So connection of interconnection. Okay. So sorry, not interconnection. Okay. Connection of two or more device networks is called a internetwork. Connection of two or more networks. This is a separate network, separate network, separate network. But we are making connection between these networks is a internetwork. Now, if you make a communication between these devices, for example, this C1 is try to communicate A1, A2, okay, or maybe B1 is trying to communicate it to this A3, okay. So what is this? It's a communication between different networks. Is called a internetwork. Is called a internetwork. Here I use a router. Router is a internetworking device. Remember, always internetworking device is a router. Okay, connection of two or more networks called internetwork. Communication between two or more networks called internetworking. Router we call it as a internetworking device. These are the simple definitions. Network, networking, internetwork, internetworking. So this is a same example, but here I have taken separate routers. Here I have taken only single router. Okay. Next one is type of networks. Type of networks. LAN, CAN, MAN, WAN. These are mainly four type of networks are there. These four type of networks are based on a geographical size or a geographical range. Okay. For example, LAN means local area network. You have a room. For example, you have a single room and you have some 10 computers in the room. So then we can create that is a LAN, single LAN. Maybe you want to create a LAN for entire floor in the building. Okay, one single floor, one single LAN size you can able to create it. Entire building, the total building, you can able to make it as a single LAN. That's it. That is a maximum size of your LAN communication. It's based on textbook geographical ranges. Means the size of size or a range of your local area network is, so it can be within a single room or a floor or a entire building. The second one is campus area network, CAN, campus area network. So if you go to universities, colleges, of course there is some tech company campuses also there. For example, Tech Mahindra or Cognizant or um, um, Tata, TCS campuses are there. Meaning is it's a combination of multiple buildings. Okay, so you go to university or colleges. So in university we have a separate building for everything, like a arts departments related building or a science department or an engineering department. In engineering department also like each engineering group, ECE, CSC, mechanical, civil, each department has separate building, right? So each building means it's a one single LAN. Building is a one maximum size of LAN is a entire building. So I want to connect these LANs together. Okay. So then make it as a big network, but within the campus only, not outside of the campus. So within the campus, we can able to communicate, we can able to control the communication between the departments, we can communicate, okay. And the size of this campus area network is up to campus. Within the campus only, we can able to communicate. MAN, Metropolitan Area Network. Metropolitan Area Network. I put all empty boxes, guys, but Metropolitan Area Network means metro cities. Metropolitan Area Network means metro cities. What is metro city? Like Delhi is a metro city. Kolkata, Mumbai, Chennai. These are the four metro cities. Now mega cities also came. So like Hyderabad, Bangalore, okay, big cities, right? So the point is you can connect different departments in the a metropolitan city. For example, fire department is there. Ambulance means like a hospital, police, water, mayor, like administrative office. Okay, so different offices. We can make them connected and make them communicate, or establish the network size within the city only, not outside the city. Like BSNL is there, Bharat Sanchar Nigam Limited. Okay. Similarly, MTNL is there, MTNL for metro cities only. Okay. So, just for example, MAN means Metropolitan Area Networks, connection of different LAN networks and make it as a very big network, but the maximum size is within the city. Next is wide area network. Wide area network. So what is a wide area network? It's a global communication, guys. Okay. For example, I have a server in Hyderabad. I have a server in Paris. I have server in Exton or New Jersey. Okay. I have a server in Pune like that. So different places we are accessing. For example, YouTube we are accessing. We don't know where is YouTube server, but we are accessing from here. Okay. It is not in your local LAN network, right? It's somewhere in the world, but we are accessing. We are accessing Google. We are accessing Facebook, right? So somewhere in this world, so we are accessing. Okay, so that is a WAN connectivity. So WAN is a global network. WAN is a global network. So these are the main four. What are the type of networks? LAN, CAN, MAN, WAN. Local area network, campus area network, metropolitan area network, wide area network. Next one is some people are add up this kind of stuff, and also there are including these things in the questionnaires part. So that's why I've written two more things additionally. That is PAN and HAN. PAN, personal area network. Nowadays people are wearing lot of things like a smart watches, smart Bluetooth earphones, okay, smartphones, okay. So everything we can able to directly connect either using a Bluetooth communication or maybe a Wi-Fi hotspot communication, okay. So they can easily connect. But network we are creating for only one single person kind of stuff, personal area network, okay. Next one is HAN, home area network. So in generally we go with the um, home automation. What is home automation means? Home automation like a smart TV, smart LED, smart appliances. Okay, smart appliances like a AC, refrigerator, or some washing machine. Now automatic washing machines also came, right? So that is when we are connecting. That is also home area network. Smart plugs also came. Smart plugs, like you can give the voice command to turn off, turn on, and that stuff. Okay, pre-programming things. Okay, assistants like Alexa or Google Home kind of assistants. These are all comes under home area network. Next, this SAN is not exactly comes under any network. That is separate concept because we don't use for our regular use purpose. Okay, SAN is by just name it is a storage area network, but storage area network is used in only in enterprises, means by organizations, not for a regular general purpose. Storage area network is based on completely a storage solution. Okay, so of course it contains a network and the limitation of network to their storage devices and storage servers, their switches, but still in originally in a landman can kind of stuff, SAN is not included. But in some textbooks and some places, still SAN is written. So SAN is storage area network, which is belongs to storage purpose only. Okay. Again, guys, LAN, CAN, MAN, WAN. PAN and HAN already told. So here it is, LAN, local area networks are used to connect networking devices that are in a very close geographical area such as floor of the building or building itself or within the campus. Within the campus means that is a CAN. Metropolitan area network are used to connect networking devices that may span around the entire city. Okay, so your maximum area of network, okay, your connection is here within the city. I will give you one example. If you know this one, in the olden days we have a cable TV networks, but in certain cities, city cable is there. City cable only within that city related information only. Now it is gone. Now we got a dish TV. Wide area network is connected to or more land present at a different geographical locations. It's a global network. Again, local area network. It's a local network means within your home. You are sitting in your home, your laptop, your mobile phone, some other laptop are connected to a same network. That is within you are in a LAN network. So you are in a simply a local network, that is a private network. LAN is a private network. Next, the size of CAN is within the campus. the size of man is within the city, the connection of devices within the city. WAN is not like that. WAN is a global network from one geographical location to different geographical location. Also, you can able to communicate because of WAN connectivity. Because of WAN connectivity, WAN is public. And there's two more terminologies there, guys. One is intranet, intranet, and internet. Intranet means local and it is private. Internet means it's a global and public. For example, I'm accessing google.com, facebook.com, w3school.com. Okay, so means these servers are located in somewhere in this globe, but still I'm accessing. So that is internet. For example, in my premises, I have a server. For example, I have a server in my local only. I'm accessing this server or I'm communicating within my server. Okay, within my local LAN network, not through internet. I don't require internet connection to access my server because it is in my LAN. So that is called a intranet. You're accessing Google. Google is not in your local location, right? It is somewhere in this world, somewhere outside. You are using internet to access google.com. That is internet. WAN connectivity, internet, like that. Global network. Okay. Intranet. Intranet is your private network. So you are accessing a web server which you developed inside your private, in your LAN. Okay. So that is a intranet. So communication within the LAN is intranet. Communication outside of your LAN is through internet, like use WAN connectivity is internet. Okay. So this is a one diagram for a small home, small office diagram. Guys, look at here. This is how we are get connected, but real time it may not shows all the things. Why? Because of we are using Wi-Fi routers. Okay. In generally, it's a block diagram like this. Okay. So here it is. I have a devices are connected to a switch or to a Wi-Fi router. So these devices in a LAN network. Ultimately, so we are communicating outside communication, right? Google.com, Facebook.com. So for that one, we have to connect it to a router, and router is connected to modem. So what is this modem? Modem makes connectivity to the ISP. Modem will make a connectivity to ISP. So you want to get connected to internet, you need a modem. Okay. To get connected to the internet, we need a modem. So while you are seeing there is a modem, router and switch. Three things are there. So you can ask me, sir, I have only my Wi-Fi router is there. I don't have this separate router, modem, switch kind of stuff. Yes, guys, because your Wi-Fi router is a combination of built-in modem. So the Wi-Fi router having a built-in modem, built-in router, built-in Wi-Fi access point, and if you see your router, there is a plug connection, like a onboard this switch connection is also there. For example, if you have one or two desktops, you can directly connect with the cable. Okay. Okay, so that's why we are unable to see multiple devices because Wi-Fi devices having all the things inside only. Okay, this is simple office, home office. Okay. Before router, your LAN. So you want to communicate outside of your LAN, we need a internet. So I will explain the default gateway. Yeah, you can say default gateway. So when you are checking an IP address, so we say IP address, subnet mask, and default gateway. Okay, we check IP address, subnet mask, default gateway. What is this default gateway? Guys, very simple to understand. You guys are sitting in a one single room. One room. Very simple. Yeah, this diagram is good, but no chance we have. Okay. You are all sitting in a one single room. Okay. So for example, to talk to one person to another person, these guys are want to talk to each other. Is it required any open the door kind of stuff? They are in the same room only. Is it required to go outside to talk? No, right? So they can simply talk to each other. I can talk to this person, I can talk to this person can able to talk to here. Okay. So I don't require any separated door or a way to go outside and speaking, not required, right? So that is like this LAN communication. For example, a PC1 is trying to communicate it to PC2 or PC3 is trying to access web server A, or PC4 is trying to access server B. PC5 is trying to access PC1 within the local network only. So I don't require this any separate gateway kind of stuff. Okay, I don't require any separate gateway kind of stuff. For example, I have a person outside waiting for me. Okay, outside of my class, a person is waiting. What I have to do it? I have to go out from my room, then I have to talk, right? In generally, what we have to do it? We have to go outside of the room and talk. How to go outside of the room? So there is a gate or a door. So go through that door. So then you can go outside, right? Open the door, go outside, right? So go through the door. So it's very simply, I put a little change of words. You have to go through the door to talk to the person who is outside of your network. Okay, like you are trying to access google.com. So google.com is not located in a LAN. So what we are doing is we are forwarding a packet through this router. Like a PC1 is trying to open google.com. So I will try. This PC1 is trying to access that google.com, means first PC1 send a packet to switch, then switch to router to modem, finally ISP to some searching and all. Finally it reaches google.com. Okay, finally it reaches google.com. Okay, so before we are going outside of our network, so how we are going outside of our network? Like this. So we are entering into this router. We are entering into this router, then only we can able to go outside. This entry point, so this is the router, right? This router's entry point to go outside, that point we call it as a default gateway. In general, when we check the default gateway, we check the default gateway IP address, which is nothing but a IP address of our router. IP address of our router. Okay. So this is the LAN communication. This is outside of the LAN communication. When you are doing it, you are going through this router. So the router's LAN interface IP address is your default gateway IP address. What is the default gateway? So whenever you communicate outside of your network, you have to go through the default gateway. Router is act like a default gateway. Not always router is a default gateway, not always like that. But most of the time your router is act like a default gateway. So what is the use of default gateway? To communicate outside of our local network. Okay. So default gateway, so in general we specify by IP address, which is our router's interface IP address. So router may have a multiple interfaces, but one of the interface which is for our side LAN network. Okay, outside LAN network. So we have IP address. So that is our default gateway. How to check the default gateway? While you are checking an IP address, you may see the default gateway address also, right? IP config also uses yes. Okay, guys, up to now.
Sir, what is subnet mask?
Subnet mask. Actually, in that will comes in IP addresses, but I will tell small notes like. So IP addresses are divided into five classes. Five classes. Out of five classes, we are using only three classes because first three are a unique. Class A, Class B, Class C. So when you say IP address, okay, when you say IP address, this IP address is divided into majorly two parts. One is network part and another one is host part. Okay, so IP address is a logical address. So when you want to connect, when you are establishing a network, like you have 100 computers are there, so you have to give IP address to each and every computer through DHCP server. Okay, so you have to assign an IP address to each and every device, right? So which IP address you have to give? What are the IP address if you give? It may not work. So you have to follow a proper procedure for that one. So you have to choose. It can be a class A or class B or class C type of IP address. And so you have 100 computers in the network. Meaning is these 100 computers must communicate each other. Must communicate each other. So in your network, you have 100 computers means all computers must be communicate each other. So they should have an address. They should have an address logically. Okay, they should have a address, IP address to communicate. But so illogically, they should in the same network kind of stuff concept. The exactly point is, guys. So look at here. Um, Roll numbers, for example, or pin numbers. See it is. I'm giving example from pin numbers, right? So 50072. 500.036. So what is this meaning? 500 meaning is you are in a Hyderabad. You are in a Hyderabad. 530.014, for example. This meaning is you are in a Visakhapatnam. You are in a Hyderabad. So how it is divided depends upon the following a, a sequence, right? You can understand 5 means it is Andhra Pradesh, Telangana and Karnataka, some places we are using 5 because British rule, right? So that is we are using 5. But the initial state, it's a capital state is right, so the 00. But 30 means it changes. If I put like this 600.123, so it can be a Chennai, okay, 400.110. It is like a maybe a Mumbai. So its significance, what area it is. So logically or physical area determination, right? And then and sub area, main area, and in that one sub area. Similarly, our IP address is also like that. Exactly say our IP address is a combination of network and host address. IP address having network part and host part of IP address. Simple rule is, guys, to make a communication between two devices, both are should be connected physically. First point is physical connectivity. Second one is IP address. Second one is IP address. So logically also must be same network. So that meaning is their network ID must be same. Network ID must be same. So who will determine this network ID? Subnet mask. Subnet mask will tell what is the network ID. Okay, you have IP address and you have a subnet mask. So while you are communicating, this subnet mask will tell what is the network ID of that IP address. Okay, while communication. If both the pieces network ID is same, they will communicate each other. They will communicate each other. Okay, so you have an IP address. IP address means it's an address, guys. Very simple. For IP address is also important is it is a simply say an address. You want to talk to someone, you need an address, right? You have to address them, right? So while you are addressing, there is a to address and from address. Normally, you have to mention your area, your postal code, your street name, house name, and everything. In a both to address and from address, you will mention. In this one, we are mentioning IP address. And we are telling to communicate two devices in the LAN, in the basic LAN network. So in general network, okay. So both the devices must have in the same logical network. Same logical network. Of course, physically they should connected, and then logically also should be in the same network. So who will tell both are in the same logical network? We can tell by network ID. So how the network ID will come? Because of subnet mask. Okay. These subnet masks are by default subnet mask are there. Sometimes people can able to change the subnet mask. So whatsoever it is, first it will verify the network ID must be same between to and from address communication. Okay. So there is a separate class for IP address subnet mask part, then we will see that. Okay, so here it is. Few more things we are going to discuss, guys. So different cables. No. Yeah, next we will going to discuss about to form a network. So what are the requirements like this? So first one is like a NIC is required, and we should use the cables. So different cables we are using to get connected in the network. Okay, of course now we are using wireless also and wired also. We are connecting different devices we use in the network. Cables, devices, protocols. So yeah, of course, topologies. Okay. The topologies, um, protocols, port numbers, IP addresses. Okay, and OSL layer model is also there. So what I'm going to do is just 5-10 minutes. So then I'm going to topologies also. We'll finish a little faster. Then. Guys, physical topology. Topology means the how it is connected. Topology means the way it is connected. Okay. Physical topology means the way it is physically connected. Physically connected. Logical topology it is means the logically how devices are connected, which is determined by IP address configuration. Just before I try to explain, right? So you ask guys like what is subnet mask? So logically how the devices are connected like that. Okay, so logically it is determined by your IP address only. The physical topology based on the connectivity. These are the main physical topologies: bus topology, ring topology, mesh topology, star topology, extended star topology, hybrid topology, point-to-point topology, point-to-multipoint topologies. Okay, I can directly go to the picture, but I want to explain always. I will do it. Okay, so just I will explain it, and later you have to study, guys. I have a computer or a devices, whatever the word you use it. These devices are connected to a backbone wire. Okay, so we have a one backbone wire using a coaxial cable. Generally, it is a big thick coaxial cable. Devices are connected to this backbone wire, so they can able to communicate through this backbone wire. It is like a olden days cable TV network only. Okay, so there is a big thick coaxial wire, and we are connected to that one. It is very easy to install. Easy to install. Okay, cost is very less. Okay, so very quickly we can able to install it. But there is a problem with this bus topology. There is a problem with this bus topology is, in case any wire is broken, the communication will stop. From further communication will stop. From AB to CD cannot communicate. AB cannot communicate C and D. So further communication will be stopped. So that's why we are not using bus topology. Difficult to troubleshoot also, because it's a very big backbone wire. So where is the issue is occur, you have to go to trace from starting to ending or ending to starting. So you have to retrace where the wire is broken. Again you have to repair. That is a little headache. Second one is ring topology. Means any topology, it means ring topology means very simply say devices. A device is connected to another device, and other device is connected to next. So like this, each device is connected to another device, finally last device is connected to the first device. Okay, so because it's this closed loop, okay, we can able to communicate in a easy directions A, B, C, D, E. Okay, so we can able to communicate. Unlike your bus topology, in a ring topology, we can able to communicate like A to B, B to C, C to D, D to E, E to A to D communication. For example, you want to communicate from A to D. So you'll have to communicate. You send a packet to B, B send a packet to C, C send a packet to D. Okay. So there is a small advantage and disadvantage is also there. Okay. So what is the advantage and disadvantages? If wire is broken, no problem. Other communication means, see, this communication is continuous. Okay. Other communication is continuous. Or maybe a device is down. Same. Further communication is continuous. It's somewhat communication will be there. Okay. But there is some problem. This is only works based on a algorithm. So when you are making a connection, you have to tell how to communicate from A to B or A to C or A to D. You have to tell entire path. Next, whenever you are going to add a new devices, for example, you add a new device. Okay, again you have to reconnect like this. That is always a big attack. Again, you have to go to each and every PC for implementing algorithm. Next, it is one-way traffic type only. So double ring topology is introduced. So very simple, guys. Ring topology means every PC is connected to another PC, not all other PCs. So a PC is connected to next PC. Next PC is connected to the next PC. Like finally, the last PC is connected to the first one, or last device is connected to the first device. So it will form a ring. So using some ring topology related algorithms are there. So using that, they will communicate each other. Okay. So anyone, uh, any possibility of guessing what topology it is? Okay.
Yes.
1 second. Very good. Now,
Star topology.
very good. I ask just for fun only to every batch. Okay. But only one person told correct answer, first person. That is mesh topology. Okay. Even myself, when I was in engineering, my lecturer told me that this is a mesh star topology initially. Okay. So because of it is a star is there now, so that's a star symbol. What we thought it is, it's a star topology. This is not star topology, guys. This is a mesh topology. Okay. So don't get confused. Just for fun only, I asked. Okay. So in generally, when we see the star, immediately mind will go to it is a star topology. What is the star topology? Sorry, what is mesh topology? Mesh topology, each and every device is connected to all other devices. For example, A is connected to B and C. and D and E also. So each device is connected to all other devices. It is not easy. It is a complex configuration. Means lot of cabling we have to use it. Lot of NICs we are using, depends upon number of devices and cable requirement. Okay. Next one is, it is a redundant. Redundant means if in case a cable is down, no problem, we can able to communicate. If device is down, no problem, all other communication is going on. And in generally, we are not using this mesh topology because of it is a complex, lot of wires are requirement is there, and number of NICs you have to keep increasing. Okay, and it is very difficult to scalable. What is scalable part again? So for example, if I add a one more device, for example, the new device is added. Now again I have to go to each and every device and make a connection, right? A to F, B to F, E to F, D to F, C to F. Again, you have to do all the connections again. So that disturb the network. Okay. So again, cabling, again calculations, again each and every device you have to go and insert the new NIC in it, new interface card. Connect a cable, you have to connect a cable, right? The PC you want to connect a cable means you need some interface card. So this is become very complex but highly redundant. How redundant? A cable is disconnected or a device is down, still other communication is not stopped. If you see bus topology, a cable is disconnected, further communication is stopped. In ring topology, a device is down, so automatically further communication will stop. Okay, so then, so one-way communication, it will happens only one-way communication, not two-way communication. Okay, but in mesh topology, no problem. All remaining communication is there. But still, we are using a mesh topology only in a organization. Like before the when I said about a LAN man can, when I say about SAN, storage area network, the SAN type of storages, they use mesh topologies. Okay, mesh topology for a redundancy purpose, like a servers, core routers, like a ISP provider having main routers are there, right? In that areas, okay, or servers, storage area networks use the mesh topology. In general communication, we don't use mesh topology. Yeah, we'll come to now star topology, guys. Star topology is required to have a centralized device. The centralized device can be the centralized device can be a switch or a hub. So devices directly connected to this centralized device. Okay, it can be a switch or it can be a hub. If you are using small network, you can go through hub. If it is a little larger network, so go to switch. Okay, this can be a hub or a switch. The devices are directly connected to it. Okay, so this topology we call it as a star topology. Okay, so this is look like a star. So first of all, we draw a star and we are telling it is a mesh topology, but it is not a look like a star. So actually the concept of star topology is like a star is brightening, right? Like a sun. How you tell like this, right? This is represent a sun, right? So it's spread out the light to all sides. So that's the concept of star. Then it is a star topology. It is. Okay. The PCs are connected directly to the centralized device. It can be a hub or a switch. The cost is there because of in all this topology we are used a cables only. But in this one we are using additional device. Second, so how it will communicate? For example, you want to communicate A to B. A send a packet to the hub or a switch and it will send a packet to B. You want to communicate C to D. C send a packet to hub. Hub will send a packet to A. Same thing. Okay, one to another communication. So how it is happen? It is going through this hub or a switch only. All communications by hub or a switch. In case of a cable is down, this cable is cut. Means only APC cannot able to communicate. If a device is down, for example, D device is down, all other communication is continuous. But compared to mesh topology, star topology is not that much reliable or redundant. Why? Because this is a completely one to another connecting. Why it is not reliable as compared to mesh topology? If this centralized device is down, all communication will be stopped. If centralized device is down, all communication will be stopped. So that's why it is not reliable. But that's the only one point, but lot of benefits are there. For example, I have another network, very simple network it is. Devices are connected under the star topology. I make a connection between this switch to this switch or this hub to this hub. Now it is become extended star topology. Means it is easy to scale, easy to configure. Star topology is easy to configure, easy to scale, easy to troubleshoot. Easy to troubleshoot also. Unlike all other topologies, mesh topology, ring and bus topologies, in a star topology, it is very easy to troubleshoot. Okay. So how it is easy to troubleshoot? We are using a centralized device called a hub or a switch. It contains a LED status whether device is connected or disconnected. First one. Second one is if in case the centralized device is down, so entire network is stop working, then immediately we can understand this. It's a problem with your hub or a switch, centralized device, hub or a switch. Okay, so we can easily trace where the issue, and if you can able to trace, then automatically you can able to fix it. And it is very easy to scalable. So for example, if you take a standard switch, the standard switch having a 24 ports. Okay. For example, in my organization, I have a 50 computers are there or 60 computers are there. So what I have to do it? I'll buy 3 switches. I connect the switches to one switch to another switch. Then I connect the computers to that switch. All 60, like a 3 24 port switches. Okay, total computers are 60, but I have taken 3 24 port switches very easily. Okay, so 3 are connected like a 1, 2, 3 like this. Different way also you can connect it, but how you connect it like this. 3 are connected now. So you have a internet like you have a Wi-Fi router kind of stuff is there, right? So you can connect a connection to from there to here. Now you connect as 2 ports are busy, means 24 port, 24 out of 24 connection, 2 connections completed. 22 connections are free. For example, I put only 20 here, only 20, only 20. And 1 or 2, each one having at least 2 are free. So maybe, may not be, we can connect later. So 60 devices, we can able to connect it. And this is passing this internet to this switch, this to this, this to this. Okay. So all 60 computers can communicate each other. And if you are connected a router, then through router we are getting internet. So obviously we are getting internet for all 60 devices. Okay, this is a formula we use in our regular network communication. So this is a extended star topology. Advantage is number of devices you can able to connect in the star topology. Easy to scalable, easy to configure, easy to troubleshoot, but less redundancy. Okay. So why redundancy is less or no redundancy part, like compared to mesh topology? So all communication depends upon the centralized device, like a hub or a switch device we are depending. If switch or a hub centralized device is down, we can't able to communicate. Okay, if this is down, we can't able to communicate. Another two things are there, guys. Hybrid means combination of two topologies, like a mesh topology, star topology, full mesh topology thing. Another one is point to point. All are point to point only, like this. So you are make a connection between two devices, that is point to point, like a to hub, point to point, A to B, point to point, A to B, point to point. Okay, so point to point, in the usually point to point we will use one router is connected to another router using WAN connectivity. We use point to point connectivity. Point to point connectivity. Okay, so another one is point to multi-point connectivity. Okay, so like this, one is connected to multiple places. Like this is one example of point to multi-point. This is also point to multi-point connectivity. Means one switch is connected to multiple switches, like this, one wire, and here it is connected to multiple things. Okay, guys, these are the physical topologies. Importantly, it is bus topology, ring topology, mesh topology, star topology. We are using star topology. Of course, there is a tree topology. Search in Google about a tree topology. In generally, there is a hierarchical type of topology. It is means main core server, or maybe core switch or router. It is there, and it is connected to the distribution layers, distribution layer to access layer kind of stuff. So that is a tree kind of structure is there. In a Google, different type of structures also there. Yeah, this is an explanation of bus topology, ring topology, mesh topology, star topology. Okay. So next one, we are going to see different cables about NIC and cables, devices we use in the network. Also, we'll see. Now take a small break, guys. Take a 10-15 minutes break. Okay. So when we will back, 12:10. So I'm going to stop recording here.